Hey, I'm Arsh and I work as a senior DevRel engineer at Metalware. In this webinar, I'm going to be talking about how you can increase the development velocity of your team by cutting down the wait times. If you've built cloud native applications, you know how frustrating the experience can get. So many times just to test a small code change, developers end up waiting from few minutes to sometimes even hours for pipelines to run, for container images to get built and all of that stuff. In this webinar, we'll be talking about why this is the case, why building cloud native applications is so hard, and we'll take a look at some of the common processes organizations use to try to solve this challenge. But we'll also look at the shortcomings of those processes. And finally, we'll talk about Mirrord, which is a tool which allows you to cut this wait time and avoid this constant redeploying that most organizations go through in order to test their changes. So let's get started. All right, let us kick off our discussion by first talking about some problems which are inherent to building cloud native applications. So first of those is that cloud native applications more often than not have a microservices based architecture, which means one service is dependent on multiple other services in order to work properly. This makes it really tricky for developers to test the code they've written for one service because more often than not, it also depends on a bunch of other services which they will need to bring up locally or in a cluster when they want to test the code they have written for their own service. Because of what we just talked about, there's a huge mismatch between the dev environments that developers are able to spin up locally versus a production-like environment. This is because when you bring up these multiple services in development, you often do it in a way which is significantly different than how they are brought up in production. Assuming you're using something like Kubernetes, a lot of config maps, environment variables, and cluster-specific configuration is involved, which becomes really hard to replicate locally. And sometimes teams just give up on that idea and don't do this locally, in which case the dev environments look significantly different from what the production environment looks like. And when you have this mismatch, it can lead to bugs which you are not able to catch during the local development phase, and then they get discovered only when you are deploying to a staging environment, and that creates a really lengthy dev loop. Why is that the case? Because when you catch a bug in the staging environment, then you have to go through the entire process of writing code locally, committing it, going through multiple pipelines, and then only you are able to test that, if the bug is solved or not. Whereas if you were able to catch that bug during the development phase, during when you are writing code, then you can fix it then and there instead of going through this loop of deploying multiple times and running multiple pipelines. Let's take a look at some of the current development workloads I've seen organizations adopt and some of their shortcomings. The first is the traditional CI workflow. Developers would write code on their local machine. When they're done writing code, they would commit it to a version control system like Git. Then CI would kick in, it would run some tests, maybe some end-to-end tests, or it would deploy to a staging environment where then you finally test it or give it to QA for additional testing. And only after the entire application has been deployed in this staging environment are you able to run end-to-end tests, because this is where your application has been brought up in a production-like setting. The problem with this is that the feedback loop is really slow. So you see how many steps there are between a developer writing code and then being able to finally run their end-to-end tests or just check out the application end-to-end and make sure everything is working. So all of these steps slow down the development loop, and they slow down how fast developers are able to get feedback, which means that once they do get feedback in this stage and they make some fixes, they again go through this entire loop, and this can create to a really bad development experience, which not only slows down your team, but also makes your developers unhappy. To combat this, a lot of organizations have started providing their developers with personal remote environments. So this is typically like an environment in the cloud where each developer has an access to their own environment, or maybe a namespace in a shared environment. The problem with this approach is that it seems good on paper, but when you start to adopt it and roll it out to your team, and as your team size increases, this can become really expensive. Even if you're not creating individual clusters per developer and just sharing a cluster, the fact that you end up duplicating the services which each developer is running because they want to run their own version of the application can become really, really expensive. And not only that, but the fact that each time you want to test out your code change, you have to spin up a new environment, which takes time because these environments at the end of the day build container images and deploy those container images. leading to developers having to wait around 10 to 15 minutes for an environment to get started, all of which slows down developer productivity. The third disadvantage is that when you have multiple personal environments and things go wrong or developers need some help with debugging things, then your DevOps team has a huge maintenance overload because now they are managing multiple environments on top of their regular work. The third approach I've seen organizations take is completely ditch cloud or remote setups during the development phase and instead rely on local tools like Docker Compose or Minikube or Kind to spin up local Kubernetes clusters or use some other tools which help with local development. The problem here also is that, again, the setup process is really slow and complex because every time you want to develop, you go through the process of creating the environment, right? Whether be it building and running containers or creating the cluster and applying manifest to the cluster. All of this significantly slows down the time it takes for an environment in which developers can test their code to be ready. The second biggest drawback is that even when you do all of this, your environment would look different from production because you are not using an actual Kubernetes cluster. You cannot replicate things like load balancer or your production networking setup on your local machine easily. So while you have an environment which is 70% like production, that 70% isn't good enough, and there will be bugs which you will fail to catch on the local machine, and then you would end up spending a lot of time just going through the dev loop again trying to fix them. And the third problem with this is that it puts a huge burden on developers in terms of having to spin up and deploy this environment. So developers need to be familiar with Docker, Docker Compose, some Kubernetes concepts in order to get their local environment up and running before they start developing. And when things go wrong and there are some errors when trying to create this environment, then they also have to spend hours trying to debug their environment issues. All of this is time which they could have spent developing the application and working on the product. Instead, now it is being wasted in trying to set up an environment. All right, so now that we have seen some of the approaches organizations take towards making developing microservices based applications easier, let us see things from a developer's perspective and see the problems they face when they try to develop cloud applications. We have already discussed some of these in the first slide where we talked about problems inherent to microservices based applications, but this should give you a more visual example of the issues developers face. So how do you develop cloud native applications when your application needs to connect to other services which are on the cluster? So let's suppose you are running microservice A and you're writing code for that. It's still possible for you to run that particular service locally, but what if that service needs a response from microservice B, which further needs a response from microservice C? So how do you test your code which you have written for microservice A without having to run B, C, and all the other dependencies locally? And running locally comes with its own set of problems like we saw earlier. Then another common scenario is that your written code or your service you're working on needs to interact with the file system of the cluster where your final application will be deployed. So there might be some files which are being generated by other microservices, and your service needs to read from those files. How do you do that locally? You can possibly try creating a mock file and go ahead with that, but the problem is that there are only so many scenarios you can cover, and it's highly likely that since your dev environment is not looking like production, there will be some bugs which you will fail to catch and which will only appear when you start to do testing in your staging environment. Then even when you are able to do all of this, how do you test the code you have written without being able to send it production like traffic? So if you have service B which you're working on, but users are exposed to your application via service A, how do you send actual production like traffic to that service in order to be able to test the code you have written for service B? All of these scenarios are really challenging and just end up creating more friction for developers when they are working on their applications. Developers having to commit their code, build a container image, wait for it to get deployed, and only then get feedback is a really bad development experience and just causes delays in their ability to ship things. It is to solve all of these problems that we built MirrorD. MirrorD allows you to execute the local code you have written in the context of a cloud environment. So what this means is that while your code and the service you have written the code for will be running locally, it will behave as if it was running inside the cluster. So MirrorD basically allows you to get traffic and data from the cluster to your locally running service. So if you have all of your services deployed in the cloud environment, and let's say you're working on this service, which is service A, you can mirror any traffic which is coming to the cloud environment to that service to the locally running version of that service on your machine. So if you have made changes, you're able to test out those changes by sending production like traffic, but also you can mirror outgoing traffic from that service to the cluster. So it would appear as if it was coming from within the cluster, allowing you to interact with other microservices and even access files or environment variables or other configuration from the cloud environment. So Mirrord brings a lot of benefits to organization, the primary of those being letting developers just ship code faster. Your developers are now able to test out much earlier in the dev lifecycle, which is really beneficial for them because that means they don't have to go through the dev loop again and again multiple times because they're able to catch bugs early on, and they're also able to test out their code this early in a production like environment, so they don't have to go through the hassle of setting up environments which look nothing like production or waiting for hours to deploy to staging, because Mirrord allows you to connect directly to your staging environment, use all these services files which your application needs and are already deployed on that cluster, and then mirror traffic between the cluster and your local machine. The second benefit is that this approach is way cheaper than setting up personal or remote environments for every developer, because in this case, all your developers use one shared staging cluster. And since teams share a cluster, that means DevOps teams or platform teams also have to manage fewer environments because they don't have to individually debug or maintain every developer's environment or personal environments. Instead, they just have to take care of this one shared staging environment, and all developers can connect to it and work using it. Let us take a look at how Mirrord works under the hood. So you have a service for which you have written the code, and now you run the process locally. And the same service is deployed in the cluster as well. So this is the pod for that particular service, and there are other services in your cloud environment including databases. And what Mirrord does is that any traffic which is coming to that service via the cloud environment, it will mirror that traffic to your local machine, so you are able to test your code and see how it behaves when it gets production traffic. But what Mirrord also mirrors is outgoing traffic. So if your process needs access to other services, or it needs access to databases or files which are there in the cluster and you don't have them locally, that will also be mirrored by Mirrord. So Mirrord would mirror that as if it was coming from this service's counterpart in the cluster. So this enables two main things. One, it allows you to test your code way earlier in the dev life cycle in a production like setting. And secondly, it takes away the hassle of setting things up locally. So you don't have to run all these services and databases on your local machine. And instead you can leverage the ones running in the cloud environment. So we'll be soon seeing a demo of how Mirrord does that. But before we get to it, I just wanted to make sure to highlight some of the things which we'll see in the demo and we have talked about so far. So when you use Mirrord, you will be able to mirror incoming traffic to the cluster, to your local machine, to your locally running process. But you'll also be able to mirror outgoing traffic, and that would get routed via the cluster. So your locally running process would be able to access all the other microservices and databases which are there in your staging cluster. Then we talked about mirroring traffic, but Mirrord also allows you to steal traffic, which basically means that when there's incoming traffic to this pod, Mirrord will just send that traffic to your local process, and this pod will not be responding. So by default, when traffic comes to a pod which you are mirroring, Mirrord sends that to your local machine, but it is your actual pod which is responsible for processing that request and sending a response. But if you use the steal mode with Mirrord, which we'll see how you can do that, then no traffic would come to this pod, and instead you can have your locally running process respond to requests which come to the cluster. Then Mirrord also allows your locally running process to read or write remote files, which can be really useful in allowing you to test in a production-like setting. And lastly, Mirrord will get all the environment variables relevant for the process you are mirroring from the cluster and then sync them between your locally running process and the version running in the cluster. Okay, enough talking about what Mirrord does. I think it's time to put all of these concepts in action and see how it actually works with the help of a demo. So for this demo, we have built an application which we call the IP visit counter. And what this basically does is that when you send a request to the endpoint of the application, then it will just let you know how many times a request has been sent from that particular IP, and it will send a message back as a response. The way this application works is that you have the IP visit counter service, which when it receives a request, it saves the IP to Redis so that it can keep a track of, how many times a request has been sent from that particular IP. And then it gets some extra information about the IP using the IP info service. So it gets the name of the sender from the IP info. And then finally, it sends the message to Kafka where it is consumed by a IP visit consumer, which just prints out a long message which you could use for telemetry purposes. We'll be focusing on the IP visit counter service, and we'll send requests to our endpoint and see them getting mirrored on our local machine. And then we'll also, see the steal mode in mirrord and make a local code change and see how we are able to get a response as well. So I'm going to close the slides and I'm going to switch to my code editor now. So I have the application cloned locally and now I'm in the repository. So this is our IP visit counter service and it has a mirrord configuration file and the service code, which is there in Golang. Before we do that, I also want to show you that I have the entire application deployed on a Kubernetes cluster. So if I get all the deployments I have on the cluster, you'll see that I have a deployment for each of these services, like the IP visit counter, IP visit consumer, IP info, and then I also have Redis and Kafka deployed on the same cluster. None of these services right now are running locally, and we'll see now how you can mirror traffic between the cluster and the local machine. But before we even do that, I want to just show you how the application works in general. So you can go ahead and send a request to this endpoint, which is the public endpoint for this application. And when you do send a request, you'll get a response which shows that, count 1, and then it has my IP, and it shows basically how many times I have sent a request. And then there's also a text which says remote is fun plus high. So if I were to send another request to this endpoint, you'll see that the count gets updated by 1, and now we see 2 here. So this is a brief overview of this application. Now what we want is to mirror traffic whenever we send a request to that endpoint. So I have the mirrord extension installed, which you can find on VS Code and for all the JetBrains IDEs. There's also a mirrord CLI which you can use to achieve the same thing, but I'll be working with the VS Code extension in this example. Once I have this, I just need to select the configuration for the service I'm going to be developing. So in my case, that will be the IP visit counter. So I'll just select that configuration file. I want to show you what the configuration file looks like, and it's a really simple JSON file where we just tell mirrord which features we want to use. And in this case, we want to use the mirroring feature, which is the default value anyways. So we have mirror specified under networking, and we also specify that we want to mirror outgoing traffic as well. And similarly, we specify the read mode for the file system so that we are able to read files from the cluster. So now that we have selected our configuration, we can just enable this extension by clicking on this dot, and then we can go to our application code, which is here. Now we can set a breakpoint and run this application. So when I click run and debug, I am prompted to select a target from which I want to mirror traffic. So I can select either a deployment or a pod. In this case, I'm just going to go with the deployment, and I'll choose the IP visit counter deployment since that is the service we are working with. So any traffic which comes to this deployment pods will now be mirrored to my local machine. So once I select the correct deployment, you will see that mirrord is starting the session. And when my session is up and running, you can already see that in our main function, we hit our first breakpoint, which is basically loading some configuration. So if I step into this function, you'll see that the load config function basically just reads a bunch of environment variables and creates a config. If we go to the end where it's about to return the config and inspect our config variable, you'll see that has a bunch of values which it read from the cluster. So these are all environment variables and things it read from the cluster, and none of this was present locally on my machine. So this is one of the features we talked about earlier, where you're able to read configuration, environment variables, and all those things from the cluster without having to, replicate them locally. Then you'll also see that here we have a response file, which is app/response.txt. And you'll see that I don't have this file locally on my machine. So if I try to, get the contents of this file, you'll see that this does not exist on my local machine. Now, this is a file which exists in the cluster, and we are going to be reading the text which is in this file. So if we go back and let's add another breakpoint here. So you'll see that it just goes through these lines, and here it tries to read the file content. And if we go to the next step, we'll see that it has read the string remote is fun from the file. So it tried to read the file app.response.txt here. And if I were running this locally, I would have gotten an error because this file does not exist on my local machine. But since we are using mirrord is allowing us to mirror our calls to that file to the cluster and then read that file from the cluster, which is how we are able to populate the string which says remote is fun. Okay, so now that we have this set up, let's set another breakpoint to when a request actually hits our service, which is here. And once this breakpoint is set, we can just have this running locally. And now when I go to my terminal and I send a request to the same URL, we'll see that the breakpoint will get hit. So when I send a request, you can already see that the breakpoint got hit, but I also got a response. So there are two things you need to understand here. One is that when this request comes to the cluster, the IP visit counter service, which is deployed in the cluster, takes that request and processes it and sends us a response, which we see here. But at the same time, the mirrord agent present in the cluster mirrors that request to my local machine, and because of which we are able to hit that endpoint. So if I were to go to the next step, you'll see that I'm able to read the same IP which I get here as a response because that is the IP I sent the request from. So you saw how we were not only able to access the environment variables and the file system of the remote cluster, but also mirror traffic from the cluster. Now, this is one use case which allows you to, test the code you have written by sending production-like traffic to your local machine. But here we saw that the response we received was from the service which is in the cluster and not our local machine. What if you want to test out the response from your local machine as well? What if you made some, code changes and now you want to test them out? Well, for that, you can use the steal mode in mirrord. So here you see that in the text we read from the file, we append a hi. So that is happening here. And let's make a change to this and let's say hello to CNCF here. And now we want to test out the response of our code as well. We want to see if this response is actually being sent to the users or not. So for this, we need to make some slight changes to our mirrord config file. So if we go here, you notice that the mode is set to mirroring. And now that we want the request to not get mirrored, but instead we want mirrord to steal that request so that it never hits the service which is in the cluster and instead just sends it to our local machine and have our machine respond to the request as well. This is done with the help of the steal mode in mirrord. And what this will do is basically it will change the default behavior where when you mirror traffic, the response from your local process is discarded and only the response from the service running in the cluster is taken into account. This changes that because now the service in the cluster receives no request because it's being stolen to your local machine. So the local machine is the one whose response is considered and shown to the user. But if you do this, you might end up disturbing the cluster for other developers in your team who are interacting with it. And that is something you might not want to do, right? You want the staging cluster, which we have connected to remain intact so that other people can continue using it as well. For that, mirrord allows you to set HTTP filters. And when you set these filters, mirrord will only steal the requests which match those filters, and the requests which don't match these filters won't be touched by mirrord, and they will hit your staging cluster and just work normally as they're expected to. So for this, we can set a HTTP filter here, and we'll use a header filter, and we'll just say that requests which have the header of XPG tenant with my name set only steal those requests and leave all other requests as it is. So once I have this set and we have made a local code change, we have changed our hi message to hello to CNCF, I think we are ready to test things out. So again, I go to my run and debug console and I just click run and debug. We select the service. And now things are up and running. So we saw this part already, so we can skip this. And now basically our service is running and listening. So first we want to verify that, it is not affecting all requests. So if I send a request to the same endpoint, it will not hit our local machine because Mirrord is not stealing this request because it does not have our specified HTTP filter set. But when I send a request which has this, filter set, now Mirrord will steal this request and it will hit our locally running process, and you see that our breakpoint gets hit. And you'll also notice that we are not getting a response here because the execution has been paused because of us adding a breakpoint. And it is only after we let this request pass that we'll see a response. So let's do that and see what we get in our response. So you'll notice that the response we get has a different text from the one we saw above. So here we saw hi appended to it, but in this case we got a response which had our local code change which said hello to CNCF, and that was appended to remote as fun, and here we see hello to CNCF. So this is what makes the steal mode in Mirrord so powerful. When using the default mode with Mirrord, you are able to test out the code by sending production-like traffic to your locally running process. But with the steal mode, you are able to test out the response of that code as well. Another use case for the steal mode is when you don't want to duplicate the changes which happen in your cluster. So if you're using Mirrord in the default mirror mode, whenever a request comes to the cluster, the service running in the cluster will make changes to the cluster, and then the request would be mirrored to your locally running process, which will also have its outgoing traffic mirrored. So it would end up making the same changes in your cluster that the service running in the cluster is making. And as a result of that, you end up duplicating the changes in your cluster. So an example for that is that let's suppose you have a service which is adding to-dos to your database. So when you mirror the request for that service, not only will the service running in the cluster add to-dos, but when you mirror that request to your locally running process as well, since outgoing traffic is mirrored, it will also add those to-dos to the database. So you'll start to see duplication of things. But if you use the steal mode, then the service running in the cluster never receives a request and only your locally running process does, which allows you to prevent this duplication of requests. Alright, so now that we have seen a demo, let's go back to the slides and have a quick recap of what we just saw. Okay, so let me do a quick recap of all the features we saw in the demo. So we saw that, when we ran our process, how our environment variables were loaded from the cluster to our locally running process. So if you remember the file path, which was app.response.txt, that path was loaded from the cluster. And then not only was that path loaded, but we also read that file from the cluster because it was not present on our local machine. So Mirrord allowed us to read environment variables and files from the cluster. Then secondly, when we sent traffic to the cluster, that was mirrored to our locally running process, and we saw this in action when our breakpoints were hit. And this applied to both incoming and outgoing traffic. So Mirrord mirrors incoming traffic to the cluster to your locally running process, and the outgoing traffic from your local process gets routed via the cluster. And lastly, we saw the steal mode in Mirrord, which allows you to prevent duplication of changes in your cluster and at the same time allows you to test the response of the code you've written as well. So we made a code change where we changed the response message being shown to the user, and we saw how we were able to see this response when we sent a request. Another favorite feature of mine which we saw was that how we stole only a subset of requests instead of stealing all the requests by setting up HTTP filters. Okay, so that was it for this webinar. I hope you found this useful. If you'd like to try out Mirrord, it is completely open source. You can go to our GitHub repo at metalbear.co/Mirrord to check the project out. And if you like it, we'd really appreciate if you could give it a star on GitHub. And if you just want to read more about Mirrord, its features, the use cases it enables, or hear from some of our users about the impact Mirrord has had on their organizations, then you can go to our website metalbear.co and read about all of this stuff. If you have any questions or feedback, please feel free to reach out to me at this email and I'll be more than happy to help you out. Thank you for watching the webinar. I hope you found this useful and have a great day.